So today we are going to talk about chi-square test first, because there was a demand for that. And then along with when we talk about chi-square test, we need to look at the uh, chi-square table or the interpretation. So I thought let me talk something about the Z table also, because when the question is asked, not only that whether it is statistically significant or not, or whether the sample represents the population or not, but you want to find out a specific number of people lying in a particular borderline or particular range. At that time, this Z table will be very useful. So I think the whole concentration today first will be on the chi-square and then Z table. Many of you might have seen the Z table, but then you may not be aware how to use the Z table for the purpose of calculating various proportion of the people. Before I start, anyone wants to ask any question? Okay, so let me share. We'll talk about the chi-square test first. Basically, what happens that we have two types of test. One is a parametric test, normal distribution curve, something like that, which follows a particular pattern. While non-parametric test, chi-square is a altogether separate thing and it comes under non-parametric test. And chi-square test, the I will start with one example where you can use a chi-square test also, or you can use standard error of proportion also. Standard error of the difference between two proportions. Let's start with a simple example, and then we'll understand. We have the reading habits, right? Let's say with a reading habit in the morning and reading habits at late night. We are comparing this. And the result is first class and distinction. And other is the second class and fail. Second class, third class and fail. Something like let's keep these two things together. And the total person reading in the morning were 200, late night 400, total 600. This is how you should be able to formulate the question also. And out of this 200, first class and distinction were 150. Here it was for 50. And here the result was 100 and here 300. So now in this case, we can apply the standard error of difference between two proportions. Now, when you apply standard error of difference between two proportions, you will have a formula whereby you convert this into percentage, right? This you can convert into percentage. out of 200, 150 are getting. So that is the 75%. Remember, in chi-square test, we are using absolute number, and in standard error of difference between two proportion, we are using percentage. It's because the proportion. Right? When you apply standard error of proportion, you are going to use Z test, which is a parametric test. But in case of small numbers, you cannot use the standard of difference between two proportion. At that time, you need to use chi-square test. Or if you have three group, four group, five groups, something like this, suppose if you are second class, third class failed, so many groups, or in this morning, late night, early night, something like that. If you have more than 2 by 2 table, standard error of difference between two proportion cannot be applied. At that time, you need to apply chi-square test. Here, it is 25%. So this is we call as P value P1. You can say P1 is equal to, and so this is a Q1 is equal to. And in this case, 100 out of 400 is 25%. P2 is equal to 25% and Q2 is equal to 75%. I do not know that most of you may not be remembering the formula for finding out the Z, right? So for Z is equal to, see, while I am writing this, I don't remember the formula. I understand how this has arrived, and from that I calculate, right? Z is equal to P1 minus P2 divided by standard error of proportion. Right? So P1 minus P2 divided by standard error of difference between two proportion. Right? So P1 minus P2 is easy. This is P1 minus P2 is equal to 50%. But then for standard error, the formula is, because I know that standard proportion is equal to PQ upon root n, or P1 Q1, or I would say that the if there is only standard proportion, you write PQ upon root n, or you make a square of it, right? So PQ upon root n, and then make a square of it, right? So what we do over here, this is combination of two. Standard error of difference between two proportion will be so if there is a standard of proportion, what you write under square root PQ upon n. But here, in case of standard of mean, what you do as the square upon n. What you say, what you are taking square root square of SD, right, upon n. Now look at the similarity. This is a square of standard deviation. That means SD into SD. Instead of, because we don't have SD over here, we are what we are doing P into Q. So that will be almost equal to SD into SD. Otherwise the same. But when you go for standard of difference between two proportion is equal to square root, what you say P1 Q1 divided by N1 plus P2 Q2 divided by N2. So in this case, in case of mean, remember this is a standard error of proportion. This is a standard error of mean. This is a standard error of difference between two proportion. Similarly, standard error of difference between two means will be here, it will be something like this. Square root of, then what you do as the one square as the one divided by n1 plus you do square of as the 2 divided by n2. This standard error formula, if you know it, z becomes very easy. Z becomes because it's the measures the difference between expected and the actual, right? So in this case, standard of proportion when we measure, and then we'll see the chi-square and what is the difference between two. Here we'll be applying this formula, P1 Q1 upon N1 plus P2 Q2 upon N2, and then we'll be taking root of it. So here 75% into 25% divided by 200. This is N1. And this is N2. Now, if we look at, we forget rest of the formulas. Now, in this case, now let us see square root of even Q1 is 25%, 75% 25%, even into Q1, 25%, divided by N1, that is 200, plus 25 into 75, 20, P1, P2 into Q2, right? 25% into 75% divided by 400. We'll calculate this, right? It will be around 9 plus divided by 4 will be around 4.5. So total will be 13.5. And if you take a square root of 13.5, roughly it will be 3.7 or so. So 3.7. Let's say 3.7. So standard difference between two proportion is 3.5. While the actual difference P1 minus P2 is equal to 50%. So if you want to find out Z, we divide by the 3.7. So 50 divided by 3.7. Let us take approximately at the 13 or so. Z is equal to 13. So Z here is more than 2. So it is statistically significant. Morning learners are having much better result compared to the late nights. Now, the same thing, if you want to use chi-square test, let's go for that, how we will use it. You can ask question in between if you have any question. Here we'll be doing calculation for chi-square. In chi-square test, what we are doing, essentially we are comparing the expected value and observed value. So this is instead of percentage, we go for observed value and expected value. Now, observed value, so this is observed value. Or let's say O1. O1 is equal to, then O2. Then this is O3, and this is O4. These are four observed values. Now we need to find out, instead of 150, what should be ideal if suppose data is homogeneous? What it should be? So suppose if you look at the result of 600 people, then 250 should be in this class. But here it is 150. So what is an expected value is that the out of 600, if this is a 250 is expected, what should be out of 200? That is should be an expected value. Expected value is equal to multiplication of this two divided by this. So it will be 200 into 250 divided by 600. Something like 84, 83. Let's give 83. 83 is expected value. That suppose if data is homogeneous, out of 600, 250 people are getting first class, then out of 200, how many? It should be this much. Now, let us consider this as a degree of freedom also. By calculating this 83, the rest of the four things you need not calculate. You can directly get it by subtraction and the multiplication, etc. Subtraction is much easier over here, not multiplication, subtraction. Out of 200, remove 83. Now, see, the concept of degree of freedom is like this. You have a freedom to change how many cells. You have freedom only to change one cell. Once you change this number, rest of the three are automatically fixed because this number will come 200 minus 83. So automatically E2 is equal to 117. Here automatically 250 minus 83. So E4 is equal to 100 square. 167. And here 350 minus 117 or 400 minus 167. E4 is equal to, so these are the expected values. Now here you can say the degree of freedom means once this you change, rest of the thing you cannot change. So what happens? The degree of freedom is equal to, this is a column, number of column minus 1 multiplied by row. These are the two are rows, right? Even minus 1. So rest of the thing, this will be the result. So multiplied by row minus 1. That will be the degree of freedom. Suppose if we have another pair, say field is a different, field is not here, it's an altogether different category. Then you will have one column, two column, three column. In that case, you can change this figure also, this figure also. And so if you have two columns or three columns, so 3 minus 1 is 2 into 1. So there will be degree of freedom will be 2. Similarly, if your third row is also there. So row, last row, this is the last row and this is the last column. That you need to always do minus because they are fixed because of the total is fixed. Total is fixed. This total remains a fixed and this total also remains fixed. And that's why you cannot move the last column and last row. That's why C minus 1. Suppose if you have table 5 by 6 table you have. So degree of freedom will be 5 minus 1 multiplied by 6 minus 1. So that will be 20. So that will be the degree of freedom. As degree of freedom increases, the chi-square value will also increase because the formula for chi-square is equal to basically for each cell we need to find out that O1 minus EY, right? Now this change, observed value against the expected value is giving some kind of change, whether the change is more or less, but that is in context to expected value. It is not an absolute thing. So in context to E1. That's why we divide by E1. Same way, once we do this, we go on adding other cells also. O2 plus O2 minus E2 expected value divided by E2. We make a square of it. Why we make a square of it? Because we want to remove the minus sign. Just like in ST, the formula for SD was square, right, root of E minus square root of at that time we were using standard deviation is equal to we were doing a square of uh, SD1 square, SD2 square, and then we were going to find out, say, same difference, right? So each cell we were doing x minus x bar, that is mean, right? With x bar, right? We were making a square of it, right? Square root of, we are doing a square of each thing, right? And then we are dividing by n. So we were doing the differences we were noting there, right? And we do the summation of that, summation of that, summation of all the squares, each divisions, x1 minus x bar square, x2 minus x bar square, all the square will be the total, then you divide it by n. This is how you are deriving the standard deviation. So same thing we are doing over here. Only thing that instead of n, we are, for each cell, the n is different in this case, right? So in this case, what we'll be doing that over, and this is, you need to continue. Square is equal to square. Then this is also square. Then you go on for each cell, you need to do this. Square O3 minus E3 divided by E3 plus square O4 minus E4 divided by E4. Because is the expected value, we are taking n over here. So make total of all, and then the chi-square value will be getting it. So I think if you can calculate it, that will be better. So 150 minus 83 and make a square of it divided by E1. Uh, some of you can start doing it. I will be putting values over here. This will be uh, 54, first one, 54. Mm, 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 but 15 minus 83, 54. Just 1 minute, I will take a 1 minute break. So we come back to the making a uh, result order. So difference between 150 and 83 divided by even, that is 83. So the result will be 67 square divided by 83. Right? Similarly, this second will be square of difference between 1, 117 and 50. That is a 67 again, because that will be the same, but that will be divided by e to 117. Right? And this case, square of, uh, again, difference between 167, 83, and this also, but that it is to be divided by 167. And this difference is square is 7 divided by 233. Now this basically we need to have a result in this cell, and then we make a total of it. We'll get a chi-square value. The first cell is 54. Mhm. 38. This is a 38. This is okay. 5, 1, 6, 7. 26, 26, and this 19. So chi-square value will be making a total of all these four. 26 plus 19. So 136 chi-square is equal to chi-square is equal to 137. Now, till now, it is simple calculation. Now, the interpretation is important for us. This chi-square test, if you had other cell, third column, fourth column, or row also, you can have 10 classes and 5 types of result. 50 cells can also be there. The advantage of this that you need not have the whole population over here, and that's why this is a non-parametrics. You can randomly take around 10 classes and then compare the results like that. Sometimes the word use is goodness of fate. And the goodness of fate is says that if your population, for example, is having a certain population, the between various group, one group is having 3,000, uh, let's say age group, other group is having 2,000, other is 4,000, like this, 3,500. And so you will have certain kind of percentages. But when you take a sample out of it, you will have another type of percentages. So whether it is fitting to this or not, At that time, also you can use this chi-square test. In that case, you take this as observed, and based on this, you find out the proportion. That ideally, what should be the proportion? Just we calculate like this. So out of 600 to 50, what should be out of 100? So if you have many groups, then accordingly you calculate expected in each. And then against expected, your observed value, you will have observed value somewhere in your sample. So expected value from the population and observed value from your sample. These two can be compared and chi-square can be applied for the test of goodness of faith. Here, if you have many classes and many the categories, when you apply this chi-square test, it is known as test of homogeneity, whether there is homogeneous distribution or not. Now, in this degree of freedom is 1 and the chi-square value is 137. So now let us go to the chi-square table and find out the interpretation of this. Now here you need to concentrate on degree of freedom is 1 over here, and then chi-square values are written over here. If you look at the value under zero point 0.05, this is a value 0.05. That means if your chi-square value is 3.8, p-value is less than 0.05. So it is significant. In our case, it is somewhere over here because it's very, very significant difference in our chi-square value. But suppose in, I will give an example. If we have degree of freedom 3, degree of freedom 3 means you have a table is 4 by 2. Table is 4 by 2. That means degree of freedom will be 3. So in degree of freedom 3, if chi-square value comes to be 7.8, then we'll call it as significant. But chi-square value is 6, then we'll not call it as significant. This 0.05 area, this is 0.05. So if it is a less than 0.05, the probability, right? This is what we say p-value. So inside is the chi-square value and this side denotes p-value. One small example, suppose your degree of freedom is 8. Your degree of freedom is 8 and chi-square value is 14. Will you call it significant or not? I repeat, degree of freedom is 8 and chi-square value is 14. The table is shared in our WhatsApp group also. Can you tell me whether it is significant or not? Can anyone tell me that? This is very important. I repeat, the chi-square value is 14 and degree of freedom 8. Is this significant? See, this degree of freedom 8. Look at the chi-square value. If it comes to 14, it will become somewhere over here. And p-value will be more than 0.05 because it is 0.1. So we'll call that this is not significant. Suppose degree of freedom is 10 and chi-square value is 20. Will it be significant? I write over here. You can refer to your table in the WhatsApp also. The degree of freedom is equal to 10 and chi-square value is equal to 20. Will you call it significant or not? Can you tell me that? Anyone? This is the degree of freedom 10. Look at the chi-square value 20 comes over here. The p-value is 0.025. That means p-value is less than 0.05. So it is significant. So look at the degree of freedom here and look at this is a zero point 0 under the 0.05. These values, this is a borderline. On this side, it is significant. This side is not significant. So I hope the chi-square test you will be able to apply and find out whether it's significant or not. Any question on this? Then we'll be going for Z table. Now Z table, I am giving an example and then we'll see how we are going to use it. Unlike that degree of freedom and probability, it is not like that. This table is of a different kind. This is a minus side and this is a plus side. So plus is on the right side of the normal curve, minus on the left side of the normal curve. And when you say the Z value is, this is a plus this. This is two digit decimal is one digit decimal. So if you want to say zero point 0.1, this is a area to the left of the Z score. If you say, let's say, usually when we use the word 2, standard deviation away, right? Z is equal to 2, then and area under the curve, you look at the exactly 1.96 if you want to see. So 1.9 over here and zero point 0.6 over here. Then 1.9 and zero point 0.6, it will be over here. If you look at the minus 1.96, then this is minus 1.9 and this is zero point 0.6. Look at this. So this is a area to the left of the Z scope. So when we say left of the Z score, when you want to measure between two Z, for example, between 1 SD and 2 SD. So 1 SD, it is 0.84134 and 2 SD is 0.97725. If you do minus this, that you will get the number of people in terms of percentage between these two, one standard deviation and two standard deviation. So logically, when you want to suppose mean, very few people are using this, but this is very useful. Mean, or let's say weight is 20 kg of children and standard deviation is equal to 2 and the total number of children is 2000. Suppose one donor says that I would like to uh, give a money for children between weight 22 kg to 24 kg. That he wants to give money 1000 rupees per child. And for children between 24 to 25 kg, he wants to give 5000 per child. Now, it is not a Z test, which is a test of significance to be applied over here. It is you need to find out the area under the curve. And remember that area under the curve is equal to 1. Suppose you have 1 lakh population, then area under the curve is 1. 1 is equal to 1 lakh or is equal to 100%. So when you use a probability, at that time, whether you can use this 1 or 100% to calculate. So 100% is equal to 1 lakh, then 50% is how much? See, so let us look at this Z table. It is point 0.1, that is 84134. Let's say for time's sake, take as a 0.84. 0.84. One standard deviation. This is a Z is equal to 22 minus 20. Looks simple. Divided by S is 2. So, in this case, Z is equal to 1. If it is a, when you take 24, Z is equal to 24 minus 20 divided by 2. So, at that time, Z is equal to 2. So, if you want to find out between 22 to 24 number of the students, here we have 2000. So if it is 100%, we'll say it is 2000. Now let's see at Z value 1 and Z value 2, what is the area under the curve? And we find out the difference between these two, because 22 to 24. So that will give us this number in terms of probability, and then we can calculate in terms of number. If you learn this, so many examples you can calculate. Now let's see 0.84 and let us go for exact figure 97725. 97725, and this is 0.83 8 84 84134 84134 84134. Now Z2 covers this much area, Z1 covers this much area. So between these two, what will be the number of people or probability is equal to Z2 minus Z1, 0.13519. In terms of percentage, it will be 13.591. So this percentage will be between 22 to 24. Now, if you want to find out 25, right, between 20 to 25, then let's find out Z is equal to 25 minus 20 divided by 2. So Z is equal to 2.5. At that time, area under the curve would be, this is Z2. Now Z 2.5, you look at over here, 2.5 is 99379. But if it is 0.5, 2.52, then this is zero point 0.02 you have to add. 0.052 you need to come over here. If it is 0.02, 2.52, then you take it over here. Is like this. This is a very accurate thing. So now I take 0.99379. So this area under the curve will be for this, right? And this is a 22 to 24. And this is minus this one. Or you can call it as 1.654%. Now, this will be the, you apply to this 2000, right? This is a unity, directly you can multiply with this. So you can say that the children who will require 5,000 rupees will be 33,000, there will be 271. This is how you can calculate. And then you can have a per rupees, you can put it over here. And then you can make a total over here. 271,000 rupees. And here 33. You can direct take this figure. Children cannot be divided into 0.02. So absolute number. The total amount you should get, apply for this 2.71 lakh plus 1.65 lakh. So approximately you require a 4.3 lakh also. This is how you calculate for a specific. It's only a question of weight, but you can have a hemoglobin level, creatine level, any kind of thing. You can use that table like this. So now I need to have a dialogue whether you'll be able to find out area under the curve with z values, minus or plus, whatever it may be, as well as chi-square, you should be able to use it. So uh, you can ask few questions, and next time we'll be going for uh, project proposals, how to write, etc. Any question? Nikar, you understood how this Z table was utilized? Usually, this is never taught in the UG classes unless there is specific. And okay. So, any other question? Have you all of you have decided your topic? Let me ask one question on the chat. If we have 4 by 6 table in chi-square, what will be the degree of freedom? Any answer? Any answer? If you have 4 by 6 table, what will be the degree of freedom? Because if you do not know this, how will you read the chi-square table? The answer is 3 into 5, 15. 4 minus 1 into 6 minus 1, 15. Now, another question. Suppose there are 6 classes and 5 type of result, and chi-square is not. It says that the distribution is homogeneous. It says that distribution is homogeneous, not significant. But now, out of the six class A and class B, if we compare only two classes, it shows significant difference. Then what do we do? Whether we consider this A and B or the chi-square we consider not significant value, what we should be considering. So usual answer would be if we are considering the chi-square as homogeneous, then ideally further two classes are not to be calculated further. Because if it is says homogeneous, there is no point in comparing the rest of the two. But if we are looking in isolation, that we don't want to look in general, but we want to look at no isolation, then you can do it. Otherwise, if homogeneous means not significant, if chi-square says that data is homogeneous, then no further test to be done. No further test to be done. This is usual dictum. But then it depends on the how the data is, right? So next time we'll be going to anybody has prepared the project proposal or the question you have prepared, you have written down your method, etc. Anuganti sir, you have uh, ready that the any project you have prepared for the student. I have to give you few suggestions. Santini, have you prepared any project where we can initiate data analysis and interpretation? Nikhar, have you done it?
No, sir. I have not done so.
So you can, it's very simple thing. I think tomorrow I will share you one Google form so that you will understand how it can be done, right? So that will give you some hint. And it takes only 10 or 15 minutes. So next time what we'll do, if you have not done, during this chat itself, we'll finish it up. I will present the how to prepare the questionnaire or etc. And then at the same time, within 10 minutes, we'll find out the discussion sample size, etc. It's not at all difficult. And then Google form you should prepare, and then we start collecting data. So our next session should be on finalizing the format, and you should be ready with the uh, Google form so the data collection can be done by our 14, 15 members. Even it is 10 or 15 sample collected, then it will be very, very interesting to do the analysis and interpretation. So, presuming that there is no further question, I end over here. Thank you.